Hello and welcome, my dear grade 9 elite students, to yet another video on my channel Mathematics Made Easy. This is Ms. Ruchika welcoming all my grade 9 elite students to today's session of Module 10 Lesson 5, Simplifying Radical Expressions. This lesson I have taken from your math book, page 603, and today's learning objectives would be to understand the important technique of prime factorization and to use it to simplify square roots. So what are you waiting for? Let's dive into the video and see what we are learning today. And before that, a humble reminder, a kind request to subscribe to the channel if you haven't still done that and you are finding the videos useful. Let's understand the technique of prime factorization. Okay, so as the name suggests, prime, that means we are going to deal with prime numbers, and factorization means the process of finding the factors. So if we have to find the factors of a given number, we are going to use this technique of prime factorization. Now, why you are learning prime factorization in this lesson basically is to find the square roots and cube roots. So let me take a very easy number 72, and now I'm going to show you the technique of prime factorization. So for 72 is an even number. So we will try to find the factors of 72 by starting to divide with the number 2. 2 is an even number. So what do you get from here? 72 divided by 2, that is 36. Again, it's a prime number, so a prime even number, so I will continue dividing with 2 till I get all the factors. So this is 18, again even 2, then you get 9. Now 9 is an odd number, so we are going to go to the next prime number after 2 and divide it with 3. So this is going to give you 3, 3 and 1. So that is the process where you get all the prime factors of the given number. So I can write my 72 as 2 multiplied with how many times 2? 3 times, okay, and 3 multiplied with 3 in a pair. Now, for example, you get your question in the exam to find the square root of this 72. That means this is equivalent to finding the square root of 2 multiplied with 2 multiplied with 2 multiplied with 3 multiplied with 3. Now, because it is a square root, I know the index is 2. So I'm going to look at pairs of numbers. So this is a pair of 2. This is a pair of 3. Pair means they are coming hand in hand 2 times. And this is the 1, 2 which is left alone. So because it is left alone, we are going to keep it inside the radical sign. Index is 2. So this 2 will be inside. Maybe I'll just rewrite this again. So this 2 and this 3 are going to go out of the radical sign because they're already in pairs. So 2 multiplied with 3 goes out, and inside you are left with square root of 2. So what is this? 6 square root of 2. So what did we do? We used the technique of prime factorization to get the prime factors of 72 and then further use the prime factorization to get the square root. So we can say square root of 72, where the index is 2 definitely, is 6 square root of 2. Okay, now pay attention, this is a radical. We had the radical of 72 with the index of 2. So similarly, your answer here is a radical 6 square root of 2. So let us go to the next slide and see what kind of question to expect from this topic. Okay, so as our learning objective says, to simplify square root. So here the kind of question that will come in your exam would be of this form: simplify square root of 72. So to simplify, you first need to write it as square root of prime factorization. So in the last slide, we've already done the prime factorization and got this. So when you simplify and write it as product of prime numbers, the final answer is going to be 6 square root of 2. Now this is the way it is given in your book, but you can skip these two steps to just simplify and make it more easy by following the method which I showed you in the last slide. That will save a lot of time, and that will also save a lot of effort on your side, and that would give you your answer in less amount of time. Okay, so let's solve one more question by prime factorization. Here the number given is 90, so it's an even number. We can start dividing with 2, we get 45. Now it's an odd number, so I can start dividing by 3. When I do with 3, I get 15 again with 3 because it's still odd, 5, and finally I get 1. So I can write 90 as 2 multiplied with 3 multiplied with 3 multiplied with 5. That's the prime factorization. Now we need square root of 90. That means index is 2. I need pairs. So what are the pairs that are here? Let's see. There's only one pair that you see, that is pair of 3. So I know this will come out of the radical, whereas 2 and 3 will be inside. So inside it is 10, outside the 3 goes, so 3 square root of 10. So definitely your answer is D. This is how you reduce the number of steps and save time while solving a question. So prime factorization, again I will tell you, is a very important technique, and we are not going to just use it in this video for square roots. We are going to use in the next video also for simplifying cube roots. Okay, let's see some more kind of questions that you can expect for your exam from this topic. Now this is called multiplication property of square root, and as you see, one square root or one radical is multiplied to the other. That's why it's multiplication. So square root of 5 is already in the prime factor form. So we'll do the prime factorization of 48. Let's begin with 2. So this is 24 with 2, that's 12, with 2, that's 6, again 2, 3, and finally you reach to 1. So you can write 48 as 1, 2, 3, 4. 4 times 2 multiplied with 3 one time. So very clear to see that this is left alone. So it will be outside the radical, and when you find square root of 48, it will be 2 multiplied with 2 and square root of 3. This is 4 square root of 3. Now, instead of solving so many steps, you can simplify using prime factorization and directly write your answer as square root 5 multiplied with 4 square root 3. Now 4 is outside the radical, so it will be as it is, whereas square root 5 and square root 3 being multiplied in the radical will give you 5 multiplied with 3, that is 15. So directly you have got 4 square root 15 without doing these complicated steps. So try to follow this method. It will save you a lot of time and a lot of effort. Okay, another one of the same type. Here again, as you see, there is multiplication of two radicals. One is square root 12, one is square root 44, and you are multiplying them both. So what is the prime factorization of 12? It's very easy. 12 can be written as 3 multiplied with 4, and 4 can be written as 2 multiplied with 2. So directly I can write square root of 12 as 2 multiplied with 2 multiplied with 3. Similarly for 44, because these are small numbers, we are just doing a factor tree instead of dividing. Answer will be same. So prime factors are 2, 2 and 11, and that's what you multiply. Now look at the pairs. There is one pair here, one pair here. So pair will come out of radical. 3 and 11 will be inside. So 2 square root 3 multiplied with 2 square root 11. Now 2 will be multiplied with 2, the number outside, to give you 4, and 3 will be multiplied with 11 to give you 4 square root 33 as the answer. So it will come here in the box. Very simple. What is inside the radical will be multiplied with what is inside, and what is outside the radical would be multiplied with the number outside. Okay, now let's do a little different kind of question. And as you see, what is the difference here? Here you have to find the square root of 63. That's the number, but you also have variables x cube and y to the power 4. So what you are going to do, you are going to basically break down into the number, the square root of the number, the square root of the variable, and the square root of the variable, right? Now let's just make it a little more easy. So 63, as you know, it's the number, so we are going to go with prime factorization. It's an odd number, so we'll begin with 3, you get 21, again with 3 you get 7. So that's the prime factorization. So you can write it as square root of 3 multiplied with 3 multiplied with 7. Okay, now for x cube, how do you write the prime factorization? X multiplied with x multiplied with x. How many times? 3 times. For y, it is 4 times. So this is how you do it. Now you take the pairs outside the radical. So the pairs are here. So pair comes out, pair comes out, pair comes out of the radical. So you get 3 outside, square root 7, x outside, square root x, y and y. Now these are already in pairs, so everything will come out. Nothing is going to remain inside. So it will be y square. Now you can combine the like terms. So 3 will be multiplied with x multiplied with y square. Why I multiplied in this way? Because this and this are outside the radical. Whereas, let me change color, square root 7 and square root x are inside, so they will be as it is. So I'm sure you have got your answer by now. Yes, you are correct. The correct answer for this question is B. Let's do one more question from your math book. This is a check question just to make you more comfortable with this kind of question. If you see here, you have square root of 147. That's the number. We are going to go prime factorization of it. Then you have three variables x, y, z with powers 3, 4 and y. So let's break it into the parts. The number, the first variable, the second variable, and the third variable. All of them have square roots because whenever you don't have any index, automatically it is 2, and you know this is a question on square roots. So let's do prime factorization of 147. It's a definitely odd number, so we will try from 3. With 3, if we do 3 4s are 12 and 27 9. Okay, now 49 is a perfect square, so I can directly go like this. Therefore I can write this as 3 multiplied with 7 multiplied with 7. Now square root of 3 x cube means x multiplied with x multiplied with x 3 times. How many times y? 4 times. How many times z? I'm just changing color. 5 times, right? Okay, now we are going to look for the pairs. Let me go blue on the color. So this is one pair, one pair, one pair. Okay, two pairs, one more pair and one more. So all these pairs we are going to take outside the radical. It comes out, jumps out of the radical. So what are you getting outside the radical? A 7 and x, two y's and two z's. Okay, what is left inside? Let's take black color. Square root 3, square root x. So I'm combining the square roots. Okay, y, nothing is left, and one z. So yeah, definitely we are going to stop here. This is the answer. So you have to combine, pay attention, the outside radical things which are in pair outside and the inside radical things which are unpaired together in this way. That's how you simplify the square root using prime factorization. One question of the similar kind that I have taken from your math book. It's a solved question, so I'm just going to explain it to you. If you see, it has four parts. One is the number, one is x, y, z, three variables. So you do the same procedure. You take the prime factorization of 525, which comes out to be this number. Pairs will be taken out. Inside the radical would be the number. So 5 square root of 21 is what you get. Then for z to the power 4, if you see, it is already having pairs, so it will come out of the radical to give you x square. If you look at y to the power 5, y to the power 4 is in pairs, it will come out to give you y square. Inside would be y. If you look at z to the power 5, it will come out of the radical from with square root of z to the power 4 to give you z square, and inside would be z left. So this would be the simplification of the square root using the same method. So that was all about multiplication. Let us see a question on division also, where you have to simplify using square root. So square root of 24 divided by 27. Now before you apply the prime factorization, before you apply the question property of square roots, you have to reduce the radicand. So inside the numerator is 24, denominator is 27. So you can easily divide by 3 to get square root of 8 by 9. Now numerator separate, denominator separate. You can always do this kind of a division. That's your question property of square roots. If you have the square root, I'll write the property. If you have the square root of a divided by b, numerator by denominator, that is the square root of numerator divided by square root of denominator. So 2 square root of 2 divided by 3 would be the answer. That is all in today's session of prime factorization and square roots for grade 9 elite. Stay glued to my channel for the next video, which is going to come up on cube roots and prime factorization. And if you found this video useful, give it a big thumbs up, like, share and subscribe to my channel. Until then, this is Ms. Ruchika signing off from today's session. See you in my next video. Bye students.